saturation, Nathan.
That's like, my number's always 82. I was like, I just got like 82 emails. Okay. I have about 15,000 emails right now. All right, use graphs and tables to find the limit as x approaches infinity of f of x and as x approaches negative infinity of f of x, and then identify all horizontal asymptotes. So the first one, f of x is equal to sine of 2x over x. And we're doing the limit as x approaches infinity of sine of 2x over x, and then the limit as x approaches negative infinity of the sine of 2x over x. And then we'll do horizontal asymptotes, but I'll save that for the moment. So they say to do these by graphs, so why not? Let's try it. If you have a stat plot on from stats class, you're going to need to turn that off.
Plot's off, you said?
Yeah.
Okay.
What is happening? Why is this not working? Then you can hit zoom trig, but mine did not show up when I hit zoom trig. So I had to hit zoom fit instead.
Zoom fit.
Yeah.
Oh wait, I have to put in the y.
Like in y equals, you type that
Yeah.
sine of 2x over x.
So put that in both
Y1.
lines.
You just need it once.
Okay.
You're just graphing the function itself.
Sine 2x. And then after that you said zoom what?
I hit trig initially and it wouldn't show up, so I had to hit zoom fit.
Where's the trig button?
It's zoom 7, I think.
Okay.
I also have to hit zoom.
What's zoom?
That's a run.
Yeah, I had to hit zoom fit as well. Whoa, that's kind of cool.
Because of how I did it, it might be a little harder to see. But basically, we're trying to look at the graph and say, as x is getting really, really big in the positive direction or really, really small in the negative direction, what's happening to the whole function. So you might kind of just have to make a guess to an extent about what it looks like. What in the world? I did something and now mine looks funny, but it's fine. I zoomed in mine and now it won't do anything but the zoomed in part. It's fine. But what does it look like is happening?
Like a little
It
squiggly.
looks like
What does it look like y is getting close to?
The what's it called? The x-axis.
So what number would that be?
0.
0. So that limit's going to be 0.
Because it's getting, it looks like y is getting closer to the x-axis. Is that what you said?
Yeah. And if you go back and look at, we had that the limit as x approaches infinity of sine of x over x is 0. That 2 being in front of the x really isn't going to change anything. It just might not happen as fast, is more or less what's happening. So then the last thing is the horizontal asymptote. So we had a rule. This is what I thought I had left out of the notes, but then I found it. The horizontal asymptote. So the line y equals b is a horizontal asymptote of the graph of a function if either the limit as x approaches infinity of f of x is equal to b or the limit as x approaches negative infinity of f of x is equal to b. So in this case, my horizontal asymptote is going to be at y equals 0 because 0 is b from that scenario. Now, obviously, we've found horizontal asymptotes algebraically before, but we haven't done them with trig functions, so. Let's see. And if we were to have a limit going to infinity, like where the answer is infinity, like the y value is going to infinity or negative infinity, there's going to be no horizontal asymptote. It's going to have to be like a specific value for there to be one. Let's see, another one out of this section, number 4. I've got f of x is equal to 3x cubed minus x plus 1 over x plus 3. So do we remember how to, in general, find if there's a horizontal asymptote? I feel like it's just a good time to review since we have one like this.
You do the vertical line test on this test or not?
Nothing. It's a bubble box.
Say, I know a clown, I think you should know.
Wait, let me see if I can remember it. Okay.
Both on.
Bottom.
So Bobo is bigger on
bottom.
bottom,
Y equals 0.
y equals 0.
Bobo, Bosco,
Bosco is
both the same.
Yeah, both the same.
Use the coefficient.
use the coefficient, and Botno?
Bigger on top.
Bigger on top.
No, there's not.
No, there's not. So what scenario do we have here?
We have bigger on top.
Bigger on top. Because it's x.
So there's none.
We have an x cubed over x, so the horizontal asymptote is going to be none. We can go ahead and answer that one.
And that's because of bot.
Yeah. Now, as far as the limits themselves, when I'm taking the limit at infinity, I only care about what?
The like largest. Yeah.
Yeah, the highest powered terms.
Yeah.
Okay, so top and bottom. So basically, I don't care about on top the negative x plus 1, and on the bottom I don't care about the plus 3. So all I care about is the 3x cubed over x. That's really all that's going to make a difference. Okay, so if I have a really, really big number, okay, so I end up with 3 times, let's just say 500 cubed divided by 500, okay, what's happening? Where's that going? Is that number getting really, really big or really, really small?
Really big.
Really, really big. Okay, so that means that that's going to infinity. at infinity. Now the other one, I've got negative infinity going in. Okay, so I have, let's just say, 3 times negative 500 cubed over negative 500.
It's gonna get over negative five. It would be bigger, right?
So it's going where?
Infinity.
Infinity. Okay, so there was a negative. The negative getting cubed, okay, is still negative. Over a negative becomes positive. So make sure you watch for signs on that when you're choosing a number to put in. And so because they went to infinity, if you didn't remember Boba Botno Bosco, or if it wasn't one that you could tell, you'd be able to do that. Now, again, you could graph this and you could see the same thing as on the graph. You would see that as it's getting really, really big this way, it's going up. And as it's getting really big this way, it's also going up. So, or I guess you could say really small.
So, for number 2, why did we do the graph on that one?
Well, so the instructions technically say to graph it and do it that way or use a table. That one, it's just easier to see that way because we don't know like all the rules of that.
Right.
The only thing you could say is I'm going to compare it to this and say, well, I know this is 0. Putting a 2 in front's really not changing anything. So I know that it's going to also be 0. That's would be typically my logic when I'm doing it. It's not changing a whole lot, so. And you could probably graph them both on the same graph and see that it's essentially doing the same thing, so you would also know then that way that it's going to 0 since it told you to graph it. Now, a lot of times when it says graph, like technically number 4 says to graph, but we can do that one just by looking at it. We don't need to graph it to see it. So it's just whatever, kind of whatever you need to be able to do to see it. So, find the limit and confirm your answer using the sandwich theorem. So, number 10. The limit as x approaches negative infinity of 1 minus the cosine of x over x squared. We want to know what that's going to be equal to. So with the sandwich theorem, I'm kind of sandwiching this between 2 things that I know, or that I know how to find the limit of at infinity. So like with this one, and this one we're about to do is going to be very similar. We compared this with 1 over x because this was sine of x over x, so I can compare it as 1 over x. And I know that between negative 1 over x and positive 1 over x, somewhere in there, this should fit. Okay? Don't really worry about the y. Just understand that it's going to. So essentially what we're going to do is we're finding the limit at infinity here and the limit at infinity here. Okay? For the negative 1 over x and the 1 over x, we're seeing what that's equal to. And we're being told that this should be the same thing. Basically. The middle part. So, I'm going to compare this one to negative 1 over x squared. Is less than or equal to 1 minus the cosine of x over x squared is less than or equal to 1 over x squared. It's not. It happens every time it shuts off. Okay. We'll just attempt to get through this problem real fast. We should probably unplug it first. Hold on. So basically, we're looking at the limit at negative, as x approaches infinity, or was it negative infinity? Whatever it was.
Yeah.
Of negative 1 over x squared and 1 over x squared. I'm just going to do this for right now because I think y'all can see this for the second until that comes back on. So what we're doing is I want to know if I put negative infinity here, okay, so let's say like negative 500, really big number, what's going to happen to this 1 over x squared?
Positive. It's gonna like, oh, negative. Oh yeah, that's right here. It would be negative still.
Well, yes, but what's happening to, ignore the sign. What's happening to that? 1 over 500 squared is what? Close to?
Negative infinity.
0.
0. 1 over a really big number is 0.
Yes.
Oh gosh. Okay. So then, same thing over here. Okay. It's not exactly, but it's close to 0. So by default then, the limit as x approaches negative whoa, this is not good. Standing and writing is not it. The limit as x approaches negative infinity of 1 minus cosine of x over x squared is going to be 0.
Okay.
Okay. Let's see what's next. Use graphs and tables to find the limits. Okay. Easier ways to do this. All right, number 14 is going to be the limit as x approaches 2 from the left of x over x minus 2 is equal to what? Try to do this one, then we'll plug it back in and see what happens. So 2 from the left is going to be what? What number could I be plugging in? It doesn't even have to be as close as I sometimes get it.
1, 2, 0,
I need something bigger. I need something semi-close to it.
3,
2 from the left.
2 come
negative.
Okay.
I'm confused.
0, 1, 2.
So
2 from the left. 1.9, yes. So we're going to say x is 1.9, just for the sake of this. If we were going to get really like precise with our calculator, I would probably do a few more decimal points, but the gist will happen because of this. So I think about this. You could graph it. That's what the instructions eventually say to do, but I'm going to show you how to do it mathematically, so you don't have to do that. So I'm going to say 1.9 over 1.9 minus 2. So 1.9 minus 2 is
negative.
and then on top I've got 1.9. So if you did 1.9 divided by negative 0.1, what are you going to get?
Negative.
You can type it in your calculator if you need to.
Is it that complicated or am I just not thinking?
Pretty sure it's just the same as multiplying like 10 or something.
Negative
right?
19.
Okay.
Yeah. Negative 19.
Okay. So we know it's going to be negative. All right, now try, since you have your calculator, instead of this here, type in 1.99999. So do 5 nines after the 1, and then do 1.99999 minus 2 on the bottom. Try that and then tell me what you get.
How many nines? Just like
I did 5. I mean, you can do however many you want, but I did 5.
Like,
I got a really big
not like negative 19,000 or
negative 199,999.
Okay, so we got a really big negative number, right?
Yes.
Negative infinity.
Oh.
Because we're dividing by a decimal. Okay, so it's going to give us a really big negative number, basically. And it's only negative because the 1.99 minus 9999, whatever, minus 2 is going to be negative. That's the whole reason it's negative.
Okay.
Now, if you wanted to graph that x over x minus 2, you could do that for a second while I'm trying to get the projector back on. If you graphed x over x minus 2 and then did zoom standard, you can look at it. We can even zoom in if you want, or zoom box around x equals 2, that area.
So put it in the y equals.
Yeah.
Are you gonna put it I mean, next time.
Yeah, you do x over x minus 2. Once you do that, you may want to hit zoom and then box. I don't remember what number that is, but if you do that, then you can arrow over, go a little bit below the x-axis, or let me rephrase, a little bit below wherever it's crossing around x equals 2, and look at it. X over.
This is what we got.
All right, so initially, something like this.
Mine don't look like that.
Does your y equals look like that?
I didn't put it in fraction form. Should I put it in fraction
Yes.
form?
Do you have, well, did your graph look like mine?
No.
Then
So-
yes, you need to put it in.
Do I
You
have-
either need to hit alpha y equals to get a fraction to come up, or you need to do x divided by parentheses x minus 2.
Alright, zoom box or zoom?
These are the same, right?
Yes.
Hit zoom 6 to start with.
Graphic right that time.
You say
Oh, I hit
alpha, like
zoom.
equals?
I hit zoom fit the first time and I got.
Oh yeah, don't do that.
Wait. But
Well, you can, but
why was it different the first time?
I don't know.
It's
Like
messy.
alpha, like,
yeah.
is that?
Oh, yours may not do it. I don't know why it doesn't. Then you're just gonna have to do x and then divide it by in parentheses x minus 2.
Yeah, that's what it is the first time, but it's so.
Did you hit zoom 6?
No, I didn't.
That yeah, you're gonna need to hit zoom 6 because it's still gonna be in zoom trig from earlier, which may throw it off. I don't know. So once you do that and you get your graph, okay, then we're gonna hit zoom and box, and then I want 2 from the left, so I need this bottom graph. So I'm going to go up above my axis here, hit enter, arrow down, arrow to the right.
Above the x-axis.
Yeah, so go up here and hit enter, and then bring it down and then bring it to the right.
Yeah. Whoa, it's tracing the box.
That's crazy because I still didn't get the right ground. It's really weird.
Whoa.
So depending on what happens, we could see as x is getting toward 2, we can see that it's shooting down that direction, which would have told us it was going to negative infinity. Yours was last year, didn't it? Hold on, you can use my calculator. We'll find a calculator you can use if you were to use that. We'll figure something out. I don't know why it's doing that.
That's just weird.
That is super weird. I don't know. We'll figure something out if there's a problem that you need it for.
Okay.
I guess if you have one that comes up something weird like that, bring it to me and let me see it, and I'll tell you what it's supposed to be if that happens. Okay. Where are we at time-wise? All right, let's look at one more, 20, and then we'll just go ahead and stop for today, and then we'll pick up the rest tomorrow. The limit as x approaches pi over 2 from the right of secant of x. All right. So pi over 2 from the right. Okay, so it's coming this direction. So just to visualize quickly here, we've got out to 2 pi. So in between here, okay, is kind of what we're looking for as we get 2 pi over 2 from the right. We're looking in this general area. So this is where it's good to know what our trig functions look like graphically. You remember what this one looks like? So if we were to graph cosine, it would go the opposite ways of the humps of cosine. So cosine would be like that. So then secant would be but I think there were, I don't have it still out, hold on. So there were asymptotes at, do I have this backwards? I might have this backwards.
Yeah, yes.
Now I'm questioning my trig graphs that I have drawn.
Calculator that's upside down. So.
These are upside down.
So we wrote them wrong in the notes.
Okay, well, we'll correct that later. This is what this should look like. That's why I was like, Something's not right. Okay, so at pi over 2, there would be an asymptote. I just need to remember to go back and fix that because that means that all the graphs are wrong. So basically, we've got an asymptote here. So if I'm going to pi over 2 from the right, that's going to be this graph down here. So what is happening?
It's going to this, negative infinity.
Yep, it's going to negative infinity. Somebody try to remind me tomorrow and we'll go back and fix those graphs from 1.6.
Got it.
I think it's just cosecant and secant that are flipped. I don't know why I did that or how I did that.
It's okay.
As soon as I looked at him, I was like, that doesn't look right. Might owe y'all a couple cookie points for that one. All right, so we'll look at some more with x approaching infinity tomorrow. There's a few more that we need to go over. And then some stuff with the right and left hand and the vertical asymptotes as well. So we'll wrap the section up tomorrow, and then Wednesday will be a review for the quiz.